In this video, we're going to cover the Octet Rule. And what the Octet Rule states is that atoms want to gain or lose valence electrons to make their electrons look like a noble gases. So what I got here are our noble gases. So we got helium with 2 electrons, neon with 10, and argon with 8. And you might be wondering, why is this called the Octet Rule? Why isn't it called something like the Noble Gas Rule? So what we got here is in our outer energy levels, we can usually fit 8 valence electrons. Our exception here would be helium, because in helium, it only fills up the first energy level, so it wants to only have 2 electrons. But if we look at neon and argon, neon fills up the second energy level, which has 8 valence electrons in it. And argon fills up the first and second and third energy level. And if you take a look, that third energy level has 8 valence electrons in it as well. So our atoms all want to gain or lose valence electrons to look like whatever noble gas is closest to them. So if we take a look at the periodic table, we'll see our noble gases on the far right side. And then we have it separated in metals and non-metals over here. In general, our metals are going to want to lose their valence electrons, and our non-metals are going to gain valence electrons. So I wrote it down here. So metals usually want to lose their valence electrons. And this is because, in general, they usually have 1, 2, or 3 valence electrons. So it's easier to lose them than to gain all the way up to 8. They'd have to gain a lot more than how many they're losing. And then the other thing is, our metals have low ionization energies, so it's a lot easier for them to lose electrons than to gain them. And then if we take a look at our non-metals usually gain valence electrons. And if you see they're on the right side of the periodic table for the most part, they usually have 4, 5, 6, or 7 valence electrons. So if they were to lose them, they'd have to lose a lot more valence electrons than however many they're gaining. And in general, our non-metals have a high electronegativity, meaning they really want to gain those extra valence electrons. So we can use kind of this split right here and knowing whether our elements are metals or non-metals to determine whether they'll be losing or gaining valence electrons. What I want to talk about now is I want to look at some elements and what they go through and what they will look like once they gain or lose valence electrons. So we're going to start with lithium. So lithium's over here, atomic number 3. So this is what a lithium atom looks like. It's got its 3 electrons, fills up the first energy level, and it's got 1 valence electron right there. So to make it look like its nearest noble gas, we got helium right here. It's going to want to lose that 1 valence electron. So remember, lithium is a metal, so it generally loses its valence electrons. So what it's going to become, once it loses its electron, remember electrons have negative charges, so it loses a negative charge. It has an electron structure, just like helium now. And because it lost an electron, it gains that plus charge. So this is what a lithium atom will become, a lithium ion now. So looking at some more examples. Next one we'll look at is beryllium. And let me show you where it is on the periodic table. You can see it's got 4 protons. So its atomic number is 4. It's right here. It is also a metal. So it's going to want to lose those valence electrons. So what beryllium looks like is very similar to what lithium becomes. It wants to look like helium again. So it's going to lose its 2 valence electrons to look like this. And when it loses those, it becomes a beryllium ion and gains a +2 charge. So that's what beryllium will become. Now we'll look at nitrogen. Nitrogen is a nonmetal and has an atomic number of 7. So it's got 7 protons. And because it's a nonmetal, it's going to want to gain valence electrons. So rather than losing these 5, it's going to want to gain 3. So 1 there, 1 there, and 1 there. So when nitrogen gains those electrons, it'll have a -3 charge. And you can see, once it gains them, it looks very similar to neon now. All right, so let's do a few more. And you might notice a pattern as we do these. We'll do the next one. We'll do oxygen. And oxygen is just 1 over, it's got an atomic number 8 protons. So an oxygen atom will have 8 electrons, 1, 2, 3, 4, 5, 6, 7, 8. 6 of them are valence electrons, so 6 of them are on the outside. So if we follow the octet rule, it wants to have 8 on the outside. So what it's going to do, it's going to gain 2. So it gains 2 valence electrons, so now it has 8 in its outer energy level, gets that -2 charge, and if you take a look, looks just like neon now. And we'll go to the one right next to it, fluorine. And if you can see where we are on the periodic table, we just went from nitrogen to oxygen to fluorine. Atomic number 9, meaning it has 9 protons in its nucleus and 9 total electrons. 7 of them are valence, 4, 5, 6, 7. Following the octet rule, it wants to have 8 valence electrons. So you can imagine what it does. It gains 1 more electron and gets a negative charge. Next one we're going to take a look at is sodium over here. It is a metal, so it's going to want to lose its valence electron. So here is sodium. 11 protons here, and the neutral atom has 11 electrons. One of them is a valence electron. And when it loses that single valence electron, this is what the electron structure will be. Very similar to a neon. So it's going to have those 8 valence electrons now. Next, we're going to do aluminum. Aluminum is still a metal, so it's going to want to lose its valence electrons. And if you take a look, it's in group 13, so it'll have 3 valence electrons. So this is what aluminum looks like. This is what it wants to become. That's what it wants its electrons to look like. And if you take a look, just like neon. So when it loses those 3 valence electrons, it gains a +3 charge. We'll do a few more. Next one we're going to do is a nonmetal. Chlorine, atomic number 17, so it's going to have 17 protons, 17 electrons in the neutral atom. You can count up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. 7 of them are valence electrons. It wants 8, so what it's going to do, it's going to gain 1 more. And when it gains that extra valence electron, it gets a negative charge because that electron has a negative charge. And you can see it looks just like that noble gas right next to it. It's going to look just like argon now. And we'll do one more. This will be the last one. We're going to take a look at calcium. If we take a look at calcium, 20 protons and 20 electrons in the neutral calcium. And it's going to have, it's in group 2, so 2 valence electrons. So this is calcium right here. And again, calcium is a metal, so it's going to want to lose those valence electrons to look just like our noble gas, have those 8 outer valence electrons in that third energy level. So what that's going to look like, losing 2 valence electrons will give calcium a +2 charge. So I'm hoping you guys are starting to see this pattern. Our metals are losing those valence electrons and getting a plus charge. And our non-metals, whenever they gain electrons, are getting a negative charge. And they're doing so to fill their octet, to fill their energy levels.